So, hello everybody. I am Substack, starting the recording. And I'm going to be talking about the crazy new things that have just landed in Browserify V2. Very Unixy, kind of almost transcendental things, but we'll get into that. So, a little bit of, well, to start with, so what I'm going to be presenting with is sort of my latest mad science experiment. So there's very well going to be some bugs during the course of the demonstration. But so this looks like a normal terminal, right? You can ls, you can like edit files, all the kinds of things you expect, except it's called exterminate, and you can exterminate some images just directly on the terminal. So that's like, yeah, it's kind of buggy, but there we go. So not only can we show images on our terminal as we are exploring the wild mysteries of Unix, we can also include arbitrary HTML. So I'm going to be just showing a lot of HTML just directly on the command line with this tool. Mad science experiment, but we'll see how it goes. So I guess the first thing I should start with, I'll just jump right into it. Browserify, here's my order of events. Talk about bundling. Browserify is a bundler. What is a bundler exactly, you might ask? So you might know from Node, you might see code like this, right, with requires in it. Whoops. Make that a little smaller. Uh-oh. OK, it's doing that thing where it's not doing the correct thing. Sorry, one sec. Mad science technical glitches. To be expected. So I'll just leave it small. So in Node, we have this wonderful thing called require. You call require with a string, and you get back an object. And the object is whatever the module, like beep.js or the gamma module, decided it wanted to export. That could be a function, that could be an object, that could be a regular expression or a number. I mean, it's completely up to the modules, what they think is most appropriate to be exporting. And that's really cool. It's especially cool because Node has this wonderful package manager called NPM. And NPM has over 26,000 modules on it. Now, I'm talking about browsers today. You might be wondering, what exactly, as a person who mostly sticks to the browser end of things, what might you be getting from a package manager for Node, a server-side JavaScript platform? Turns out that there's an awful lot of code that's been tested and published to Node through NPM that just happens to work in the browser with this tool because it doesn't really depend on the server-side part of it. It just depends on particular APIs to be in place, particular core APIs, and the module system. So we can get a lot of the benefits about what's been exploding in Node with tooling, and this is a tool. So anyways, back to this example. Node is really great because you can do requires, and you can't really do that in the browser. I mean, there's things like require.js with AMD or whatever, but those are different from Node, so it's just kind of gets weird. I don't know. I'm not going to talk about that, but this way is very nice. So here, we've got a beep function, and we've got a gamma function. We can call our gamma function and just do some crazy arithmetic on it. This is different from Node, right? This is document.createText Node. You can't do that in Node. And this is document.body.appendChild. So what exactly how can these possibly, these two contrasting worlds, how could they possibly find some common ground? And I will show you. So you type Browserify, main.js, and that's it. And so you get back on standard out, in the Unix tradition, you get back some text. This happens to be JavaScript text. What's cool about this text is it's got just this little prelude right here that makes all the require magic happen, but it's very small, new in V2. And then it just has all of the functions that we were using to build our source. So if instead of writing that to standard out, we'd redirect that to a bundle file, and then if we have an index.html that includes that bundle, this is it. I mean, just script src bundle.js. Now we can show that example. Here I'm using magical, crazy mad science to show that example, and it prints out beef. Notice how that's in a different font too, just to to prove to you that that's actually HTML that's being rendered. Not only that, it's actually rendering JavaScript. So that is really cool. So if you want to start decomposing your front-end code the same way that you've grown accustomed to, or at least I have, and I think a lot of other people are increasingly coming to this conclusion, if you want to deconstruct, or sorry, if you want to organize your front-end code in the same way that works really well in Node, you can use Browserify, and it will just resolve all of your requires for you. Notice also in this example that gamma is not a local file. That's not a relative path. That's actually a module that has been published to NPM, and we're just using it in our code without any problems. So that was really cool. Let's see what's on the agenda next. All right, built-ins. So it's not exactly as if Browserify can just go about its job without kind of hacking away at a few things. But it turns out that this is really useful. So what I mean here is that a lot of Node modules that have been published to NPM happen to depend on things that are in the core library. Now, luckily, the core library in Node is very small. It has things like query string and URL and path and fs and net, datagrams, buffers, that kind of stuff. Luckily, there aren't too many things, and quite a few of them, over half, we can actually use in the browser with some browser-specific code. So the first example here is just using the path module. Wait, sorry. Yeah, we'll go with that example first. So this example just requires the path module, right? So this isn't from NPM. This is resolved by Browserify dynamically based on some custom shims. So for all of the core libraries, Browserify will insert a custom shim if it has one. And then we just have a little logger here that will dump some pretty text for us, basically like console log, except on document.body.innerHTML. And then we can just call things that we are accustomed to calling in Node in our browser code, so like path.normalize. I've run into a lot of cases in front-end code where I actually want path normalization libraries, and I don't want to just copy-paste from some Stack Overflow post and hope that I got it right, and hope that whoever posted it tested their solution correctly, and it's something reliable. I don't want to waste all my time doing that. I just want some path module to do that for me, and Browserify lets you do that. So here, we're just going to print with HTML what the normalized values are for that path and what the relative path between beep boop and /robots is. So to do that, we just browserify path.js, and we write the output to static bundle.js. And then we can show that index.html file. Cool. So here, the first one, we've normalized the path. So it got rid of all the /slashes. And in the second one, we've taken the relative path. So it's sort of like the inverse operation almost. So we've gone from the absolute path and the relative and made a relative out of it. So cool. And notice Comic Sans on the terminal. It's pretty cool. So that's cool. That's paths. There's some other ones that I think are neat. So query strings are cool. Node has this really sweet module called query string. It's sort of obscure almost, though, but it's been in core since, like, I don't know, a very early version. What's cool about having a query string module is that you can parse query parameters, like on the query string in your JavaScript code, and that's sort of hard without some framework helping you out or without some library you copy-pasted from some website, some forum post somewhere. So here in this example, this is another neat thing about exterminate, the terminal program we're using here. It actually can take a query parameter when you show an HTML file, so we can play around with it a little bit. Anyways, we'll create a text node with what the result is of calling query_string.parse here, and we'll just put that on standard out. So it's very simple again. To browserify that, all you do is browserify qs.js and pipe that to static, like bundle.js. And then we'll show it. So exterminate show static index.html. OK, cool. So it's an empty object in Comic Sans this time, because we haven't specified any query string parameters. But if we actually specify some query string parameters here, like beep equals boop and xyz equals 555, then it got parsed. Cool. That's really useful. This is an example of something in core you might want to use. I've got just one more example here of something in core you might want to conceivably use in your front-end code. And then there's some more advanced examples I'm going to be showing pretty soon too. So the URL module is really neat because this is something that's really annoying in browser code. If you want to just take a URL and decompose it into its parts, you get that for free on the window.location object because it's done that for you. But if you want to do that like for an arbitrary URL, you have to go and copy paste some code somewhere that some guy wrote that one time, which is annoying. So here we can just call url.parse, and it works exactly like in Node because it is exactly the same code. I did the copy pasting here. I copy pasted from Node's source code and put it into Browserify's source code. Well, some other module, I didn't want to look at it. But so if we run this example, you can see static bundle.js. You can see that I have copy pasted it, in fact, correctly. So exterminate show static index.html. OK, so, oh, right, it takes a query string parameter, I'm pretty sure. So we do http substack.net/beep boop, and just ignore that. Cool, so that's like, that looks legit, right? Protocol http / is true, host substack.net, query, some random gibberish, path name, path. Oh, this is nice too. You get like the host versus the host name. So if you have a port, that can totally mess with your Ajax in local development, and then you'll be screwed in production for some reason. Yeah, so all this has happened. Anyways, in a nice iframe with scroll bars in Comic Sans. It's cool. So basically, the impression that I'm trying to give is that, in fact, there are a lot of core libraries in Node that are very handy for front-end development. It's not something that us, like, server people should get to hoard for ourselves forever. Actually, mostly it's just that I want to keep pretending that I'm not even in a browser anymore. I want to just keep writing the code that I'm accustomed to. That's mostly it, but it's very nice, I assure you. So next up, we can look at something a bit more attuned toward like how you would integrate Browserify into a more traditional app where you already have code and you just want to, oh, I just want a couple of modules from NPM. Yes, you can absolutely do that. So, all right. So if you use the -r command, so here we're loading some modules. We're loading HyperQuest from NPM, which is a module I wrote. It's basically like request, but tinier, and it turns pooling off. And it just so happens to work in the browser because the HTTP module has also been shimmed out in Browserify. So you can do http.request in your browser code, and it will work pretty much exactly like your Node code, including the buffering, the data events, and the end events, and all that kind of stuff. Hooray! You don't have to keep that horrible monstrosity that is XHR2 in your head anymore. It's been copy-pasted away somewhere in some file that one time. So if I run this, we'll generate our static bundle. And that static bundle is really cool because it will let us do things like here, I've just got another script tag, right? The first script tag includes the bundle. The second script tag is just, it's just some script tag. So we can require modules by calling require. You don't necessarily have to always be using Browserify from like your main.js outward. You can actually use it more piecemeal in this way to sort of, I don't know, buttress some existing code, or maybe this way just you like it better. That's fine. So anyways, we'll require HyperQuest. We'll require another neat module called through. It's actually a streaming module, but because the through module only depends on the stream API node, which has been shimmed out by Browserify, you can use it, and it works great. And I use it all the time. So we'll use URL like before, and then we'll just drop in some DOM stuff. So we'll make a pre-tag, and oh, this module is really nice too for browser code. I've just only recently started to appreciate this, but url.resolve, if you give that the base path, and you give that a second path, then it will like do all of the resolving logic for you. It's very nice. And it's like even more useful in front-end code. I rarely use this in Node code, but in front-end code, it's really useful. So anyways, we'll just load this file from disk called turtle.txt in our Ajax request, basically, with HyperQuest. and then we'll just append the result. This is cool because if this were a very big file, we would get the chunks incrementally, and we would see the results as they streamed in. We wouldn't have to wait for everything to come in like you would with jQuery.get or something like that. I think really streaming abstractions fit a lot better with what's actually going on behind the scenes, and it makes it so that you can avoid writing a lot of tedious code to like paginate your request responses and all that kind of noise. Anyways, exterminate show static index.html. So this should do our AJAX request for this mysterious file called turtle.txt. What could it ever look like? ASCII turtle. Great. So it just fetched that from my local web server here, so it actually did a round trip. So this magical terminal wizardry, it still works. And then it econ refuses because I killed the process. Anyways, so that's pretty cool. You can use Browserify in such a way that you can just require from code that's not being bundled by Browserify itself. What's next? So next up, we've got pipes. Right, this is getting more to the crux of the title topic for this, which is called Browserify and You, unix. Because it's all about decomposing things into small interoperable pieces that fit together like Duplo blocks or like garden hoses or whatever kind of metaphor you want. That's basically the idea. So with Browserify, for V2, there's some really cool stuff going on. So here in this directory, I've got a bunch of files. They're all sort of interdependent, but it starts at the main.js. So if we look at main.js, we require foo and bar and a logger, and we do some stuff, whatever. And then in foo, we require baz, and we do something ourselves. And it's sort of this interdependent module thing. Treating the files individually on disk, though, doesn't really lend itself for the kinds of algorithms that we want to be running to generate the bundles in the first place. So in starting on the version 2 refactor, I was like, this is too hard. I don't want to really do this all in one place because that would just not be obvious how to start. So I was like, screw it. I'm just going to make a separate module, and I'm going to call it module deps. And what that module will do, I said at the time in the past. So you give this an entry point, and it spits out JSON data. So this is all of the files in the dependency graph. The only thing that module deps does is it traces out the dependency graph. So it includes all of the file names, all of the source strings, just as strings in the JSON output. And you can just parse this JSON. If you use a streaming parser, it's even better because you don't have to buffer the whole thing into memory even. So if you have an absolutely massive bundle, you can just piecemeal compile it. So this is really cool, but how do we go from an object like this into something that we can drop into our web page? So that's where this other module called Browserpack comes into play. So Browserpack, if you run it, does nothing because it's waiting for you to write data to it on standard in. So we can close it, and so this is what you get to generate an empty Browserify bundle, basically. It's just some require kludge that's actually been pre-minified for you because it's ugly to look at. I just want to kind of smush it up in the top of the bundles, and then it's OK. Anyways, so Browserpack has been written to take input from module deps. So if we just pipe module deps output, and it's just streaming JSON output into Browserpack, then what do we get? Well, we basically get Browserify. That's basically all that Browserify is doing in just those two tiny modules that are completely independent. They've been published completely separately to NPM. And if you wanted to come along and write, I hate Browserify, I'm going to write my own Browserify with something slightly different. Sure, you can do that. It's very easy. You just start with these two modules and diverge wherever you want. So this gets us to 85% of what Browserify is doing. Another 5% is this other module called insert module globals. Unfortunately, that has to know what the entry files were because it sort of has to insert special things for some special file names. So when you do this, you get all of the stuff that Node programs expect. For instance, a lot of Node programs expect a process object to exist in your scope already. You might have seen this if you've done any Node when you call process.nextTick. So in Browserify V1, it would always insert that. But if you didn't ever call process.nextTick, your files would be really big, needlessly. And then, of course, where do you stop once you start inserting stuff? I mean, maybe we should include the buffer, but buffer is really big. We absolutely don't want to include that by default. I mean, process.nextTick was pushing it, certainly not buffer. So we can't ever have that feature unless we detect using AST analysis. So I'm using a couple of modules, Sprima, and this other module I wrote in the wilderness in Australia called, I don't even remember what it's called, it's lexical something or another, lexical scope, I think. And it looks at what all of the globals are that are expected in your scope. So if your program that you want to browserify has buffer in it with capital B, then this part of the pipeline figures that out, and it inserts it automatically into your final bundle. So you don't really have to worry about module authors on NPM accidentally, oh, they use buffer, so I can't use this module, or they use process.nextTick, so I can't use it, because everything has been shimmed for the browser, but only when it's needed. So your bundles aren't going to get really big for no good reason. It just might be a little slower to bundle it, but you can turn that off if it's getting too slow. So these are the three main pieces that sort of sit behind the scenes in Browserify. And all of Browserify is doing, well, it's doing kind of a lot of things, but mostly it's just sitting around that main pipeline chain. And it's sort of massaging the inputs a bit and kind of massaging a couple of things about the output. And it also lets you do things like transforms. Well, module packs. Module depth actually does the transform stuff, which I will get to shortly, because that's very interesting. Anyways, long story short, Browserify, more Unix, less features, I think was the announcement for V2, because I took out a lot of features in refactoring this because they didn't belong, and they were best handled by plugins, which I will get to, I think, shortly. I'm not sure how shortly. All right, it's worth noting, one thing that actually got rid of, or that I got rid of intentionally, was debug mode. Debug mode in Browserify V1 used this hacky source URL trick. I don't know if any of you are familiar with this, but it doesn't actually matter anymore, so you might as well not have this piece of knowledge ever in your head. But you can actually, in any JavaScript file, have this special comment called source URL. So it's like, double / at source URL equals, and you give it like a file name path. And then the browser will say, oh, well, this file came from there, so when I show stack traces, I'll show them as coming from the file specified in the source URL comment, not from where it actually was. The tricky part is, if you want to actually have a bunch of files in the same file, like Browserify, how it bundles everything into one file, that's tricky because the only way that that works in browsers is if you put them in eval blocks. So Browserify V1 in debug mode, you would put everything into eval blocks, which is really horrible. Even the good kind of eval block, I don't know if anybody's familiar with this, but there are two kinds of eval blocks. One of them is good. Well, no, sorry. Both of them are evil. One of them is slightly less evil. That's functioning with the capital F. It's kind of nice because you can pass in parameters explicitly. Anyways, the other one is some weird keyword thing. So got rid of all of that. So all of that I just said, you could just, oh, yes, awful things were got rid of. Good riddance. Except the problem was you couldn't actually debug your code, right? When you have an exception in your application, it gets thrown somewhere in this 40,000-line bundle.js file. You can kind of like click on it in the debugger and figure out kind of what's going on, but it's tricky. So here I've got an example of that. Tricky and not tricky, I should say. So Browserify, this is just a simple app that throws an exception in one of the files. So Browserify main.js static bundle.js like before. And we can, exterminate show static index.html. So it didn't actually do anything here. A neat little lie I've been showing you, this whole time I've been in a Chrome app. So it's not actually a Chrome app, just like a decorationless Chrome window. And so this is actually a browser that you've been watching the whole time. This is a more traditional looking browser that's also been watching the same thing. Oh, it looks like it got stuck. Let me run this again then. Wah, wah, wah. OK, cool. So now it's synced back. So if we exterminate show that file without debugging turned on, Uh-oh, down here at the bottom, you can hardly read it, but it says uncaught error, beep boop, bundle.js line 12. That's kind of silly, right? We don't actually care that it was bundle.js. We know that. All of the code lives there, so it could only possibly be there. If you want nice stack traces in Browserify, it's very simple. All you need to do is add --debug. And now, if we exterminate show, okay, so now there's a second error down here, right? Uncaught error, beep boop. But look, now it says foo.js line 5, and if we click it, we actually see exactly where in the file that was. So the bundle doesn't actually have foo.js in it, and foo.js isn't actually accessible. We could take this bundle and like throw it on S3 or something without throwing any of the other files at it, and it would still give us exactly the same behavior. This is because there's actually, in debug mode, this wonderful little hack that not me discovered. I just thought that it might exist, but turns out that it actually does exist, and it's very awesome. It's called source mapping URL and source contents URL. And basically, if you have a special comment like this with inline base64 encoded source maps, then you don't actually need to ship the map file along with your bundle, because they have like relative requires, and everything gets really weird because you have to like take all of your code and like uplift it all at once and like go over here and drop it down in production, and it gets really weird. Anyways, this just inlines all of that because it's completely silly to do it any other way, I think. And if you need something different, you can just use a tool to pull out these source map annotations and drop them into a map file or whatever. Anyways, the main point of this is just pass --debug, and then you get nice source maps. If you're running a very modern version of Chrome, or I think Firefox is getting this very soon. You do have to use a very modern browser, but once you're doing that, it's just no-brainer. Just, oh, --debug, there are exceptions. I want to know where they are. Cool. So, right, static assets. So static assets are kind of neat, right? Because, well, they're kind of horrible, I should say. I should rephrase that completely and say the opposite. Static assets are kind of terrible because if you want to be writing small, tiny, focused libraries to sort of structure your application with loose coupling between all of your pieces, well, if you have a bunch of static assets that all of your pieces are actually dependent upon, then when you want to actually reuse those pieces, you have to bring all of the static assets with it. And that's sort of frustrating. So one way, and it's not applicable for every single case, but it's very nice for a large number of cases, I would say, is to bundle your static assets into your JavaScript files and then use DOM code to sort of bubble it up. So here I've got an example of that. So this example uses a Browserify source transform. And so this source transform looks for whenever you var fs equals require fs, it knows that. And it's actually looking at the AST. It's not just doing some stupid regex. Although you can still trick it very easily. So it's not terribly robust though. Anyways, you do fs.readFileSync in your front-end code, which is completely silly, right? That's front-end code. What are you doing read file sync in there? You can even have things like dir name. How could that possibly work? Well, it's known at compile time. That's how. And it just evals it, whatever. Anyways, the point is, when you have code like this, and you run that through a Browserify source transform called brfs, then you can do something really magical. So to specify a source transform, we do -t or -- transform, and we can say brfs and give it the main.js. And if we just look at that output here, if we dig into where the source definition was, remember how that was var source equals fs.readFileSync? Look what happened. Now it's a string. It's been inlined. That's pretty cool. So you don't have to worry about like shipping your assets along with your bundles because you just stuff them in there with nifty tools like this. So this example, I forget what it actually does. I think it should draw an image when we run it. So let's run it. Browserify main.js, -t brfs, and static bundle.js. And then if we exterminate the static index.html, we should see, oh, sweet, some HTML on our terminal. Like, you could obviously load this in a real web page, but that's not as fun. Cool. So that's pretty neat, but there's actually an even cooler trick you can do. That image was actually external. That hit my website, my substack.net, to fetch that image data. But what if we want to inline that image using the old base64 encoded data URI trick that some of you may be familiar with? So here we do the fs read file sync like before for the page.html. Then to get the image, we also do an fs.read file sync here, right? But as the second parameter, and this is taken exactly from Node, so what's cool about this is if you don't interleave your code with DOM code, you can actually run this code exactly in Node, and it will behave pretty much the same way, except you have to worry about strings versus buffers. Anyways, so once we do this with the second parameter of base64, we have a base64 encoded string that we can drop into an image tag with the data URI trick that looks like this. You know, data colon image png base64 comma and then the base64 encoded string. Awesome. Anyways, let's just run that, right? Make sure that I'm not just completely off it, and that this actually works. So static bundle.js, cool, and then exterminate show static index.html. And cool, so this one didn't actually go out to my website because the image data was inlined into it internally. So if you need to ship something like a little button with an icon on it or something small like that, that's a great use case. Or for CSS, for instance, or little HTML snippets or templates, you can use transforms to inline those into your source code. There are also a bunch of other transforms that I won't get into, but there are a lot of transforms that are on the Browserify README at the bottom that show how to require a Jade template or a stylus thing, whatever that is, and have that be inlined and compiled on the server side so that you only get the final products into your static assets. So neat. So what else is there to show? CoffeeScript. How many CoffeeScript users? Can I get a show of hands? I know that's a horrible thing to do in presentation. OK, so lots. Great. I'm not a CoffeeScript user, but I think it's important to support, in the interest of diversity, like Browserify supports supports your lifestyle choices. I don't know how to phrase that. Anyways, so here, I just wrote some CoffeeScript, just now actually, just like an hour ago. I don't know what I'm doing really, but I know that it doesn't have parentheses, so I removed some parentheses. And anyways, so I require a file, but say you are a CoffeeScript user and you want that awesome source map stuff I was just showing. How can you possibly get that? So here I've got something that will blow up, right? Undefined.fn. I don't know, I just made that up, but the CoffeeScript compiler likes it, but runtime doesn't. So how can you possibly catch exceptions like that in your code? Well, it's really easy because all you need to do is nothing. Browserify main.coffee instead, and then specify this module called Coffeeify. So npm install Coffeeify, and that's it. And if you want to publish npm modules with Coffeeify in them, you can actually add a special field into your package JSON that will automatically run the Coffeeify, and this goes for the BRFS stuff too, or any transform. It will automatically run that transform for your package when somebody requires it externally, so you don't have to ship compiled code in your packages. It's great. Anyways, so like I was saying, you need to do nothing. Browserify-t Coffeeify main.coffee, and then just like, well, so let's just do that to start with, right? Just like in the other example. So we'll exterminate that, exterminate that CoffeeScript. So here in, whoops, let me just re-show that. So it'll show up in the debugger fresh. OK, cool. Uh-oh, cannot read property head of null. OK, that's not the error I was expecting. Let's run Browserify again. I think that's a different error. Just guessing. OK, so if we run Coffeeify and show that static file, and I'm just going to reload this page. Uh-oh, OK. Oh, it crashed. That's why. Never fear. I can quickly restart this. We're in the coffee example. So we'll exterminate static index.html, but only after we load it. Cool. Great. That's where we're. Whoa, whoops. Okay. Run that. Oh, whoops. I didn't say show. Should have caught me on that. Okay. Okay, great. So object is not a function. Perfect. That's the error we were expecting. Problem. I didn't catch that. Anyways, object is not a function. Bundle.js, line 9. That's kind of too bad, right? Because that's exactly like before with the debug stuff. So what if we just say debug? So here we will say Browserify with -t copyify, and we will add --debug into that, like so. Now, if we run exterminate show, okay, we get the same error. Object is not a function, but look, main.coffee instead of bundle.js. So now we actually have the stack trace with the file offsets, all taken care of by that same source mapping trick that I was just showing. Awesome. So if you're a CoffeeScript user, you can just use the Browserify transform and get all of the magic of Browserify with your CoffeeScript. Great. Whatever. Getting towards the end, but the last thing is really cool. So definitely stay tuned, as it were, for that. The other thing is, if you're using code a lot in Node and the browser, then you want things that work in both places for testing too. And so one module that I want to show real quick for that is called tape. This is the interface. I don't know if anybody's familiar. It's the interface that's used by the Node tap module. And basically, if you have tap tests, you can replace require tap.test with just require tape, and it will work in the browser. So here, we've got a test, right? It's kind of just a stupid thing, t.oktrue. Most boring test ever, right? What's cool is we can just run this in Node, and it passes. But if we browserify it, so browserify test.js now, and we'll just write that to static bundle.js. Now if we exterminate show static index.html, over here, cool, look at this. So at the bottom here, this is tap output. This is a common test output. And we've just console logged our test output. Now it's very easy to write like your own thing to trap these console log events and to just stuff that into a WebSocket or something. I've got some modules for that, and there's others on NPM, like TapeDeck, for instance. Anyways, this is very cool because we now have the same tests running in Node and the browser. Now, my startup, I'll just plug this very briefly, but my startup actually has a service that's free for open source modules. So if you have something on GitHub, you can go to ci.testing.com to set up GitHub webhooks. You don't have to make any accounts. It's great. Just go to github.com, and on your project settings for the hooks, you just add git.testling.com as a webhook URI thing. And once you start pushing to GitHub, you'll get badges like this. It's great. So here we've got tap output for this other project of mine called dnode. So what's cool about this is these are the same tests that are also used for the server-side code, but I'm running them in browsers too. And you can catch things like when browsers mess up, like all of the IEs often, as you might expect. So that's pretty cool. The last and final thing I want to show is a musical experiment that me and some friends of mine have been working on. So this is called Baudio. Baudio is just a little JavaScript API for defining functions, callbacks, that take a parameter t that's time in seconds and return an amplitude. That's a float between -1 and 1 inclusive. And all you have to do is return an amplitude with respect to time, and that's all that music is, right? I'm pretty sure that's basically it, right? So you just write some code that returns some amplitudes that sound pleasing, and I can just run this. So I'll just run this in Node, and what's it even called? Right. That's what that code sounds like. That's on SoundCloud, by the way. Anyways, So that was really cool, but how can we make it even cooler? Let's run that in the browser. You can do this. So my housemate, Johnny, actually published this module called Web Audio, which very cleverly, if you just take the letters in Audio and you add WE, is Web Audio. That's kind of neat. Anyways, so there's this Browserify transform field you can use to sort of make browser-specific versions register when you require like a module. So here we're requiring audio, but we're actually getting the Web Audio module instead. So when we do that, Browserify is really smart about that. So if we Browserify main.js and write to static bundle.js, now if we exterminate show that web page now, so this is running in a web browser with the Web Audio API instead of in Node. And it's exactly the same code. And that's sort of the crux of what Browserify is. It's like, you just write stuff the Node way, and it's like, hey, tools, figure this out. Do your Unixy magic, and just leave me alone. Anyways, thanks.
Yeah, I think we got some time for questions. So if anybody has a question, raise your hand, and I'll bring the mic over. There we go.
So how much of Browserify is like a direct port versus you just emulating the behavior, et cetera, et cetera, et cetera?
I would say most of it is just, well, I don't know, maybe half of it is just taken directly from Node. And then I added a couple things, like to make it work on crappy browsers, they don't have object.keys or that kind of thing. But basically, that was the starting point. I guess the biggest divergence, like obviously some things just don't make any sense at all, like datagrams don't make any sense to have, well, not yet. WebRTC maybe at some point. But yeah, most of it is just directly taken, and not much has been done to it. So the module that actually handles this is not mine now. Browserify used to have all of this in itself, but I didn't want to manage all that. So I got someone else. I tricked someone else into managing it. It's in a module called Browser Resolve that takes care of all of that stuff. The biggest departure, though, I would say, is the HTTP module, because that actually patches XHR to work like Node's core HTTP. So that was a bit of work, but not too much.
So I used the Browserify in the past, but only for like small little projects. I wonder, maybe it's a question for anybody here, if you guys ever used Browserify on a medium, bigger size project, and I want to know how you guys organize your code. Maybe you can talk to me after the talk and showing your GitHub page or something, because I'm really curious. Do you have anything about organizing big? I know you hate big projects, so.
Yes, I do. But I can tell you what not to do. This came up in a Stack Overflow question by a guy who was actually working on the same company as a friend of mine. Anyways, so got great background details. One thing that you absolutely shouldn't do is overuse relative requires. If you find yourself like going back 4 or 5 levels with like ... slashes, stop. A good way to get around that is to use Node modules. If you don't want to publish that necessarily into a separate Git repo or a separate NPM package, you can do that. You can check things into Node modules or do symlinks, or have, in the package JSON of NPM, you can actually specify Git URLs. So if you have private Git URLs, you can do that. Or if they're public, that's even easier. But there are a lot of tricks. But a big one is just don't use too much relative requires, because that's just really wrong.
Any more questions?
If you've maybe you mentioned this when you were mentioning require.js, but how different is it than the Node style require? And if you have code using require.js, can you still leverage some of this, or is it a completely different animal?
It's easier now to leverage code, or to leverage Browserify with require.js code. There's a few modules that people have worked on So one guy, Florence something or another, wrote Browserify-FTW for the win, and that package will programmatically transform script calls from the require AMD style to the node style, so that you can use them for Browserify. If you don't want to quite go that route, now in V2 we've got a bunch of stuff for doing separate bundles. So by default, if you Browserify main.js, you get just one big bundle. And if you want to start breaking that up, we've got a couple of extra options now, like -x, and there's actually 2 standalone mode. So this generates a UMD compliant build, so it puts all the required decoration around it for like all those crazy other things, including browser globals, if you happen to have nothing at all. So there is a good migration path now, I would say.